So this is what the problem looks like. Two cars are 500 meters apart and they're driving towards each other. So car A has a velocity of 10 meters a second in the east direction, while car B is starting at rest and accelerates at 2 meters a second west. And then the question is how long before they hit each other. So I'm just going to draw a simple diagram. So this is going to be car A right here. Car A. And 10 meters a second. So its velocity, I'll say velocity A equals 10 meters a second. And then of course you also have to set directions for everything. So I will set east to positive. And now there's a distance between them. So it's going to be like 500 meters. So let's draw a line like this. 500 meters. And then there's car 2 over here. Or car B, I mean. And its velocity at the start. So velocity B is equal to 0 meters a second. But it does have an acceleration. So it is an acceleration of, what is it, 2 meters a second squared? Yeah, so 2 meters a second squared. Acceleration for B equals 2 meters a second squared. Nice, okay. And now we're going to put this into a formula. So there's two different objects, right? So they're both going to have their own little formula. So what we want to find is when they're hit the same position, right? So we can assume this one's accelerating, so it's probably going to be around like right here, right? Now at that point, we want to have the same time, so the same delta t, and then they're going to have the same position, which is, so d final, position final, right? They're going to have the same position and the same time at that point. So at that point, we know that we need to find the same time or the same distance, right? So you can do either or, but I would find when they're at the same distance first and then just see what the time is. So what you're going to do for that, so let's do car A first. So car A's displacement, we're going to say, we'll set the origin to right here. So we're going to set the origin to right where car A starts. So car A's displacement is going to be whatever d final is over here. So we're going to say displacement equals d final, right? Because you have to subtract the initial position, but there is no initial position, it's 0, right? Well, there is initial position, but it's 0. And then delta d, you can just use simple kinematic equations, so it's just going to be time multiplied by velocity, right? So we'll say delta t and then VA is going to equal final position. And then car B over here, so its final position is going to be, it's going to be the same thing, but its displacement will be a little bit different, right? Because remember, it's delta D position 1 or position 2 subtract position 1. It's DI, so original position is 500 meters away from the origin. So it's going to be like delta D equals DF subtract 500 meters. Right, so, and then you're just going to rearrange this because again you want the final position to be on one side, so delta D subtract 500 meters. Actually, this is plus 500 meters equals final position. And now put in delta D, so you use one of the equations. So in this case, we'll use the one where it is, like we'll use kind of this one right here, so time times velocity and then plus 1/2 acceleration delta t squared plus 500 meters equals df. But now there's no initial speed, right? So I'll just take away this, and you will get this right here. So now notice how df and df, right? And again, these things are equal to the same thing. So we can just put these two equations together, which will get you delta t. And I'm also going to fill in the variables. So VA, that's equal to 10 meters a second, and it's in the positive direction. So I'll say 10 meters a second. And that is going to equal 1/2 times acceleration. So acceleration is 2 meters a second squared, and then it's also west, so I'll just write west here. And west is in negative, so it's negative 2 meters a second squared multiplied by 1/2, and that just becomes 1. So negative 1 meters a second squared, and delta t squared plus 500 meters. Okay, and then you just rearrange. So you're going to put everything to one side. And then I'm going to take away all these units right now, because just to make things easier. So this becomes positive when you move it to the other side. And then plus delta t, 10 delta t, minus 500 equals 0. And then again, you just solve for time now, so you just use quadratic formula. So delta t equals negative 10 plus or minus. Okay, if you don't know quadratic formula, you got to make sure you remember it. I'm making it plus 4 because it would be negative 4 times negative 500, but I'm going to take out the two negatives because they just multiply together to equal positive. So okay. And now you just put this number in your calculator, and you should get two numbers, because remember it's plus and minus, so you should get 17.9 seconds. So that's positive 17.9 seconds, and then negative 27.9. And then, of course, you can't have negative time, right? So you can just take that out. So that would be your answer. And then let's say on your exam or test or whatever you're studying for, it asked the displacement for each one after that amount of time. You would just replace, like you just go to this original equation and you just replace like 17.9 multiplied 17.9, like that. You take the time and you just put the time back in, right? Let's do that really quick. So let's say, what is the displacement for, we'll say velocity A, or for car A, I mean, which is kind of like the crash site, right? What is the position, we'll say. So for this one, you would say df equals, we'll use this one because it's probably the easiest. So 17.9, and you'd want to use all the decimals. I don't have all the decimals with me, so times 10 meters a second, that's positive, and you'd get df equals about 179 meters, course east. So that is where they hit each other, which is, yeah, about like, yeah, kind of where I said, like right around here. So actually maybe a little bit more, yeah, like about there. All right, so that's all for this one. Let's move on.